Hello friends, today I will discuss the distributors. What is distributor? Distributor is nothing but a line which supplies power to the several loads or main lines. These distributors are two types. One is called DC type distributors, the other type is called AC distributors. In this video, I will discuss only DC distributors. DC distributors are four types. Number one is DC distributor fed at one end. Second is DC distributor fed at both ends. Third is DC distributor fed at the center. The fourth one is ring main distributor. So let me consider one after the other. First one is DC distributor fed at one end. In this case, here AB is a line called the distributor. At several points like C, D, E, loads are connected. These loads are nothing but main lines. Each load will draw the current. So here at C current is I1, at D current is I2, at point E the current is I3, and the total current supplied by the supply is I. And here the supply is connected to the point A. This is called feeding point, or this is the supply given to the distributor. Second distributor is DC distributor fed at both ends. In this case, line AB from here to here represents the distributor, and at end A one supply is connected with voltage called V. Similarly, another voltage source is connected at point B like this. On the distributor at point C, the load connected is I1. At point D, the load connected is I2. At point E, the load connected is I3. At point F, the load connected is I6, and the load connected at point G is I7. These loads are nothing but main lines connected to the main services connected to the DC distributor AB. And here assumed the both ends are fed with same voltage VV. Similarly, there is a third type of DC distributor, that is a DC distributor fed at the center. So here also AB line represents DC distributor with several loads connected at various points on the distributor like this. Here this is one load, this is another load, this similarly this is another load, this is another load, and whereas at the center of AB the feeding point is connected whose voltage is something like V, and the point at which the DC distributor connected is point C, and from this point current will flow from left to C, similarly right to C towards B. Similarly, there is a fourth type of DC distributor, that is called ring main distributor. In this case, the distributor is in the shape of ring like this, with several load points connected at point B, C, D, E, whereas at point A the supply is connected, or this is the feeder point, to the distributor. Now let me discuss the numerical problems on DC distributors. To solve any problem on DC distributors, we should know what are the questions that will come from there. The numerical problems on DC distributors will ask only 3 questions maximum. One is area of cross section of DC distributor, or it may ask the voltages at various load points, or it may ask minimum voltage point on the distributor. These are the 3 questions that will come. So when the questions are like this, what is the procedure to be followed to solve any DC distributor problem? The number one is, first, according to the data, first draw the diagram. Example like this. So they mention the length of the DC distributor and the loads at which they are connected with respect to point A, that also they mention, and the load currents also mentioned, and the supply voltage also mentioned, that is feeding point also mentioned like this, and each section the distance also can be calculated. This is the drawing the diagram as per the data. Next, this can also be drawn like this as a closed circuit to find the voltages at various points in the circuit. Next step is calculate the resistance in each section. Each section means in this block, in this block, in this block, in this block, or here, here, like that. So then find what is the section current. Section current means whatever current that flows in this section in the distributor is called the section currents. Load currents will be known. Once that section currents are known, then find out what is the voltage at various load points. Load point means here. So what is the voltage across at this point means point C means this voltage minus the voltage drop across this. Because the current is known in this section, and also the resistance is also known, so VA minus RAC IAC is nothing but the voltage at point C. Like that, at point D also can be calculated, at E can be calculated, similarly at point B also calculated. So let me take a first problem on DC distributor fed at one end. The data is given like this. A two-wire DC distributor cable AB is 2 kilometers long and supplies the loads of 100 amperes, 150 amperes, 200 amperes and 50 amperes, situated at 500 meters, 1000 meters, 1600 meters and 2000 meters with respect to the feeding point A. Each conductor has a resistance of 0.01 ohm per kilometer. Determine the voltage at each load point when the feeding point voltage is 300 volts, that is at point A. To solve this problem, first step is draw the diagram, next calculate the resistance in each section, then find section currents, then find voltage at all load points. So as per this data, first draw the diagram. Here the distributor ends are mentioned as AB, and this total distance is 2 kilometers, and at point A feeding point is connected which supplies 300 volts, and there are load points at point C 100 amperes, at point D 150 amperes, at point E 200 amperes, at point B 50 amperes loads are connected. So having known the Kirchhoff's current law, we can calculate what is the current flowing here. That is this 50 amperes, here also 50 amperes, so same current flows here. Whereas here, apply the KCL and find out what is the current here. So 200 plus 50 means outgoing currents are equal to the input currents to the node E. So 50 plus 200 is the current that flows between D and E. Then similarly here at point D, a load carrying 150 amperes. So find out what is the current flowing in CD branch. So again apply the KCL here. So 250 is going out, similarly 150 also going out. Add these two currents, then 400 amperes is the current that flows in the section CD. Similarly, apply the KCL at point C and find out what is the current flowing from point A to C. That is, outgoing current is 400 amperes and here also 100 amperes. 400 plus 100 will give you 500 amperes, and that will flow from point A to C, while currents 400 amperes, 100 amperes flow out of point C. Once this is done, so now it is time to calculate what is the resistance in various sections. So here a distributor means it will have the forward path and also a return path, means there are two wides. So if the resistance of one wire is 0.01 ohm, which is given for kilometer, so then the total resistance of the distributor per kilometer can be calculated as 2 times small r. The small r is per conductor resistance per kilometer. So 2 into 0.01, so 0.02 ohms is the total resistance of the distributor per kilometer. Whereas in sections the distance is different. In RAC the distance is 500 meters, whereas this is for 1000 meters. So RAC value can be calculated as 0.02 into 500 divided by 1000. So for 1000 meters the resistance is 0.02, whereas for 500 multiply that with 500. So I will get here 0.01 ohm. Similarly for CD section or CD, so here also the distance of the section is 500. So the resistance in this section is 0.02 into 500 divided by 1000, and it will give 0.01 ohm resistance. Similarly RDE, here the section distance is 600 ohms. So whereas the resistance for 1000 meters is 0.02, for 600 calculate like this, 0.02 into 600 divided by 1000, that will give 0.012 ohms. Similarly REB is nothing but 0.02 into 400 divided by 1000, and that will give 0.008 ohms. So across all sections the resistance is calculated and current at each section also calculated. Now those calculated section wise currents also can be written like this: IDE is equal to 250 amperes, ICD is 400 amperes, IAC is nothing but 500 amperes. And now calculate what is the voltage at load point C, that is VC, that is here. VC is equal to VA minus IAC RAC. IAC is known, RAC is also known. Substitute those values. IAC is 500 amperes, whereas RAC is 0.01 ohm. So I into R. So here is 300 volts supply voltage, feeding point voltage. So 300 minus 500 into 0.01 means 295 volts is the voltage at point C, that is at point load C. Similarly, to get the voltage at point D, so voltage across CD must be subtracted from the voltage at point C. So that is VC minus ICD or CD. So VC already calculated, so ICD also known, RCD is also known. So substitute those values here, then we get VD value is 291 volts. Similarly VE also we can calculate, so that is VD minus VDE. So we know what is VDE. VDE means it is nothing but IDE into RDE. So that is 291 minus 250 into 0.012. So after simplification, we get it here 288 volts. Similarly, endpoint VB we can calculate by subtracting IEB REB from VE. VE is already calculated, that is 288 volts minus IEB is 50, REB is 0 into 0.08 ohms. So from this we get VB is equal to 87.6 volts. Let us take a new problem on DC distributors. Here DC distributor is fed at both the ends with same voltage of 220 volts, and the length of the DC distributor is 600 meters, and the ends of the DC distributor is A and B, and loads connected are 20 amperes, 40 amperes, 50 amperes, 30 amperes, and they are tapped at distances 100 meters, 250 meters, 400 meters, 500 meters with respect to the end A respectively. If the area of cross section of the distributor is 1 centimeter square, determine the minimum voltage point on the distributor and assume the resistivity of the conductor as 1.7 into 10 power minus 6 ohm centimeters. So with this data, the minimum voltage point has to be obtained. So first step is draw the diagram. Next step is calculate the resistance in each section. Then find the total current IA and also section currents. And then step 4 is find the voltage at point B. And similarly identify where is the minimum voltage point on the distributor. In this case it is going to be point E, at where the current reverses. And we know a DC distributor means it will have the forward path conductor, similarly return path conductor. So the length of the conductor will become 2 into L, and in that case total resistance will become rho into 2L divided by A, and single conductor resistance will become capital R by 2. So here conductor resistance is given. So here conductor resistivity is given as 1.7 into 10 power minus 6 ohm centimeters, and we know what is the total resistance of the DC distributor including both forward path and return path. For 1 meter length we can calculate as 2 into 1.7 into 10 power minus 6 into 100 divided by 1, where this 100 represents 100 centimeters, divided by 1. A is also given as 1 centimeter square. So with this we get resistance of DC distributor for 1 meter length as 3.4 into 10 power minus 4 ohms. Then we calculate the resistance in various sections of the DC distributor, that is RAC is nothing but 3.4 into 10 power minus 4 into 100. So 3.4 into 10 power minus 4 is nothing but DC distributor resistance per meter. So for 100 meters means multiply that with the 100 meters. So then we get 0.034 ohm. Similarly, resistance in section CD is nothing but the resistance per meter into 150 meters, which is the length of the section CD. So that gives us 0.051 ohms. Similarly, the resistance in section DE, RDE is nothing but 3.4 into 10 power minus 4 into 100, that will give us 0.051 ohm. Similarly, resistance in section EF is nothing but REF is equal to 3.4 into 10 power minus 4 into 100. is equal to 0.034 ohms. Similarly, in section FB, resistance RFB is nothing but 3.4 into 10 power minus 4 into 100 is equal to 0.034 ohms. Similarly, now the voltage at point B we can write as voltage at point A minus voltage across section AB. So here both the sides voltages are known, that is at point A and point B. So they are at 220 volts. Only thing is here this equation has to be written just to know what is the unknown current called IA. Look at this diagram here. So these are the feeding points, feeding 220 volts here, similarly here 220 volts, and the load currents are given here, and then applying the KCL and assuming that the current is flowing from point A towards point B. So assume that the total current is IA, and then we can calculate what is the current flowing here. IA minus 20 is nothing but this section current. Similarly, by subtracting this from this, we get this current here. Similarly here, this current we get by subtracting this current from this. Similarly, this current we get by subtracting this current from this. So in this equation, substitute all the values, VB value, VA value. VA is nothing but 220. Similarly, VB is 220. And IA is not known, but RAC is known, RCD is known, RDE is known, REF is known, RFB is also known. Substitute all the values. This will become single equation with single unknown. So from that we get IA value as 61.7 amperes. Once this is known, then the section wise currents can be calculated, ICD, IEF, etc. ICD is nothing but IA minus 20. So that gives us 41.7 ampere. Similarly, IEF also, we find out IA minus 110, that is nothing but minus 48.3 amperes. Similarly, other section currents also we can calculate. But here current in section EF is becoming a negative. That means current is reversing instead of moving towards the point B. Means point E is the minimum potential point. So now we can calculate what is the minimum voltage VE using this circuit. So to get this voltage, subtract the voltage drop from here to here from VA. That is what we have written here. VE is equal to VA minus IAC or RAC plus ICD or CD plus IDE or DE. Substitute all the values. Then we get 220 minus 4.31. So that is nothing but 215.69 volts. Let me summarize once. So in this video we have seen what are the different types of distributors, and we have seen the types of DC distributors, and we have seen what are the numerical problems that comes from the DC distributors, what are the questions that can be expected from the DC distributors, and we also saw how to solve DC distributor numerical problems, and we have seen two types of questions. One is when the DC distributor is fed at one end, how to find the various parameters in the circuit in the distributor. Similarly, the other problem is when the DC distributor is fed at both the ends, and we have seen where the minimum voltage point will occur, and also we have seen it in various sections the currents flowing and also the resistance of various sections.